Next up, we have Ben Baumer. He's a professor in statistical data science program at Smith College. He's a co-author of the Sabermetric Revolution and Modern Data Science with R. Ben provides a pretty unique experience of the fact that he worked for the New York Mets from 2004 to 2012 and was transitioned to an academic research role.
So lead into my talk. Oh. Why do I have to sign this? Why do I have to sign it?
You have one.
You not just allowed to see my tweets? Alright, well, I'm going to wait a second. What's our hashtag here?
Hashtag
Oh, I'm not going to do it. Okay, I'll just wait. I have it here on So, this is from a talk earlier this morning. Brian Burke said, if every team plays to their mean, the better team will always win. You want to get away from your mean. And this sort of provides a perfect segue to what I'm going to talk about. And I guess the first question I would ask is that true? So if every team plays to their mean, what he's talking about is, what I assume he's talking about, is their sort of mean performance. And so there's variability for each team in any given game. But if everybody plays to that mean level of performance, will the better team always win? What do you think? Yes? No? Maybe? Sometimes?
Yes.
Okay. But there's some variability, right? And I think part of what's exciting about sports and why we all waste our time thinking about it is that there's you don't know the outcome until the game, right? It's like that's why they play the game. Even when you know who the better team is, there's some element of randomness that's involved, and we need to actually play the game to find out who's going to win. And so this whole project started, actually, Greg and Mike and I were at the joint statistical meetings talking about the NBA finals that had just finished. And I think we all agreed that we had the sense that when the NBA finals were over, we felt like the team that won the NBA finals was like probably the best team in the NBA that year. But in baseball, World Series is happening right now, and this is a bad year because they actually are probably, certainly two of the three best teams. But in general, in baseball, like I don't always have that feeling. Right? The playoffs in baseball feels like it's a little bit more random, and so we wanted to explore these ideas, and that's where this comes from. So this is about luck and parity in sports. And so as we were just talking about, the best team doesn't always win. Sorry, Houston. We don't have the data for 2017, so I don't know if they're actually the best team. But how often do they win? Right, so how often does the best team win? And does that vary from sport to sport? Is that something that is universal across sports, or does it matter? And this all sort of feeds back to this, what I sort of consider to be like the seminal idea of sports analytics is like, how do we untangle luck from skill? We know that both are involved. We know that teams win because of skill. We know that teams win because of luck. But how much of each of those things is present in each case? Okay, and so this measure of luck is going to lead us towards notions of parity. So here's what parity looks like. Parity wears a mink coat. This is Joe Namath flipping a coin at the Super Bowl, and we believe that if this is a fair coin, that both of those teams have an equal chance of winning the outcome of that coin toss. And so this is one notion of what parity looks like. This is not parity. So this is Kristaps Porzingis of the New York Knicks playing one-on-one against Darren Ravel of ESPN. And this is a situation where like we don't actually need to play the game to know who's going to win this. So this is not parity. So when we set out to investigate this, we're gonna develop a couple different notions of thinking about these questions. And so one notion is like, at a given, a fixed point in time, what does the distribution of team talent look like? What level of parity is there across the league? But also in terms of the postseason tournament, like, do the rules of that postseason tournament serve to reinforce those notions of parity or counteract them? And apart from that, how does that level of parity change both within a season over time and then across different seasons? We're going to develop each of these things. So we're developing a cross-sport model, although Greg, you don't agree that it's a cross-sport model. It's the same model fit to different sports. Do you agree with that?
I agree with that, yes.
Okay. So, and this all started where we, our work builds off of a paper that was published by Glickman and Stern in 1998, in which they were looking at the NFL, and we've sort of adapted that. So, one of the challenges that we face in doing this work is that wins and losses are noisy. Right? And what I mean by that is that a win or a loss is a 1 or a 0. But that 1 or a 0 is not an accurate reflection of the difference in quality between the two teams, even how they played in that game. Right? And so the next thing that you could try, and this is what Glickman and Stern did, is you can go to point differential. Right? So maybe a measure of how different the teams were is reflected in the difference in the score. The problem with this is that we want to apply the same model to different sports. And the distribution of point values in games across different sports is very different. So 1 point in the NBA means a very different thing than 1 point in baseball. It hurts me even to say it. Okay. And so the solution is if you can't use their numbers in a statistical model. So what we are actually modeling are the betting odds. And what we believe is that those odds give us really like humanity's best estimate as to what the actual probability of either of those teams winning that game was going into the game. Right? So, so to make it clear, we're not modeling wins and losses. We're not modeling point differential. What we're modeling are the actual implied probabilities based on the betting markets. And there's lots of evidence that these betting markets are efficient. This is some sort of quick and dirty estimates that we did, but what you're looking at here are the implied probabilities based on the betting market on the x-axis and the actual observed probabilities on the y-axis. And as you can see across all 4 of these sports, this is across 10 or 11 years of data, there's really not any evidence that there's much inefficiency in this market. And if there were, like Greg and I would be in Tahiti instead of here. On a beach, something, yeah. Okay, so the model that we built, so again, what we're modeling is the probability that Team I will beat Team J in Season S during Week K of Sports League Q. So across 4 sports, across each week of those of 10, I think it's 11 seasons, and then we're modeling the probability that Team I will beat Team J. Also factored in here is a league-wide home advantage that's constant across all teams, but then also each team has a team-specific home advantage. And what we're going to fit is a logistic regression model where those betas that you see are estimates of the team strength. So again, we're going to estimate those team strength parameters and the home field parameters based on the response variable, which is the probabilities implied by the betting markets. And there's a couple tweaks in there to center the theta so that they always sum to 0 every week. And then we have these gamma, so gamma week and gamma season are parameters that control how much these team estimates are allowed to vary from week to week and from season to season. Right, so we know that the quality of the teams changes on a week-to-week basis, but then also on a season-to-season basis. Okay. So yeah, as I said, so we purchased this data. I'd love to share it with you, but we're not allowed to. We have shared all of our materials on GitHub, except for that. But we have 11 seasons worth across the 4 sports. And what we're going to fit is a Bayesian model, the results of which we'll talk about in a second. So what this allows us to do is to make statements about the probability that one team is better than another team at a given fixed point in time. So you guys hate the Cardinals, right? You get that right? No. Okay. Pirates fans hate the Cardinals, all right? Yeah. I hate the Cardinals. So what you're looking at here is what the posterior distribution of those team strength parameters looks like at the end of the 2013 regular season for the Cardinals and the Pirates. And you can see that this allows us to make a more nuanced comparison of so it's not obvious which was the better team, right? You can't just go based on the record, but this gives us some way of thinking about how sure we are that one's better than the other. We can back up then, and we can look at how those team strengths, so now we're looking at sort of the means of each one of those things that we saw before, but now across time. So this is across each week of that 2013 season, and you can see how sorry, Pirates fans, this doesn't look good for you. But chances are that the Cardinals were actually a better team than the Pirates that year, wire to wire. Sorry. And then, so again, stepping back, looking now across multiple seasons and across multiple sports, we can see how these team strengths evolve over time. And this is obviously, sort of too much data to sort of interpret. There's a couple things that stand out. One is that if you look at the NFL in that 2007 to 2008 season, you can see one team that was clearly elevated above everyone else in the league. Yeah, okay, there you go. That was the New England Patriots, who went 16-0, and then lost the Super Bowl. This is regular season data only. The other one that stands out is actually right above that in the NBA. You can see a team that kind of dips down there. So that was the Miami Heat that year, and they started off 8-18, which is not good, but not terrible. And they won their last game of the season, but between that they went 6-48. And so the bettors picked up on this. Okay. So one thing we can look at is, so these are the gammas now. This is measuring how much the team strengths are vary from season to season, right? So at the end of every season, there's free agents, players leave, players sign, and yet somehow the teams, to some level, kind of stay the same. Good teams stay good, bad teams stay bad. But how much? And so what we can see here is that hockey seems to be the least consistent, and that's true. That's a blanket statement. Sorry, Sam. But hockey teams seem to be the least consistent from season to season, and teams in the NFL seem to be the strongest season to season. And we heard anecdotal evidence of this earlier, where I forget who mentioned it. It was basically if you have a top 5 quarterback, your team's going to be good. A lot of other things don't matter as much. Looking at the week-to-week evolution of team strength. So here we see that baseball and hockey, which sports that tend to play a lot of games very quickly, they seem to be very consistent from one week to the next. The team strengths don't change that much. Again, I think this accords kind of with our intuition. In basketball and football, a key injury to a key player, that could change the team strength. Remember, this is the betting markets, right? So it changes instantly. As soon as that injury report is out, that parameter can change instantly. Okay, so what this allows us to do, and the details of how we did this in the paper, but to come up with a parity metric for each sport that measures this unpredictability at a fixed point in time. And so at one end of the spectrum is Joe Namath with the coin flip, where every team has a 50% chance of winning every game. And at the other end, we have the Harlem Globetrotters, who always win. Okay? Don't bet against the Globetrotters. But in between that, we have all 4 of these sports leagues. And based on our analysis, it's the NBA, sort of as we suspected. This is sort of where we started out in the first place. That shows the most, the closest to having the outcomes predetermined than the other sports, with hockey and baseball considerably further along on the other side. Okay. So the next question we talked about was, well, how does the postseason tournament either sort of confirm or not support the results of the regular season? And so we concocted a simulation to imagine that if you took the 16 best teams according to our team strength parameters at the end of the season and forced them to play a regular tournament, and these are 7-game series in every league with 16 teams in every league. We don't have to worry about concussions in these simulations, so we can actually play the games. And what we see, again, is that the NBA, and to a slightly lesser extent the NFL, the postseason tournament, it supports what we get from the regular season, that the best teams do win a lot of the time. Whereas in baseball and hockey, it seems much more random. And so looking at this in a slightly different way, we asked ourselves, well, okay, so 16-team tournament is pretty unrealistic in football. What happens if we look at an 8-team tournament? So now we only take the best 8 teams. And what you can see here is that in football, in basically all the sports except for basketball, this sort of pseudo R-squared parity metric that we've concocted, all the sports have similar levels of that metric except for basketball, which stands alone in terms of having the postseason tournament really reinforce what happened in the regular season. And I think it's funny, I don't know if it's funny, but with the NBA season starting right now, the World Series happening right now, and I'm already reading articles about how the basketball season is basically a foregone conclusion, and it's going to be the Warriors and the Cavs in the postseason again. And what we're seeing here is that the teams that win the regular season probably are better, or they are better, and then they tend to win in the postseason as well. And this is a question, I think, for the league officials. It's like, is this what you want or not? And I think there's arguments on both sides. Right? So in the NBA, I can imagine as a player or an executive feeling like, yeah, I want the postseason to reward the best teams. Because my work is based on working hard and being good at my job. And I want to get that postseason glory, 2 Stanley Cups, right? But if you're a fan, maybe this is not what you want. Maybe you want it to be wide open and have every team have a chance at winning the postseason, even if they're not the best team. And this is clearly the approach taken by the other schools. So I think it's a philosophical conversation for them to have. So I'll skip through this in the interest of time, but we have some stuff here about the home advantage. And then who cares, right? So GMs need to predict the future. Our estimates of team strength, we believe they're better than win-loss. We can show that they predict future win-loss better. And teams need to know how good their team is in order to decide if they want to trade players, like to trade them out or whatever. I think I'll just skip this. Most of the hard work here is done by Greg and Mike Lopez, who could be with us today, except for in sweater form. So our paper is on the archive, our code is on GitHub. The slides that you see here are on, I need to update that link, but they will be at that link. And so just to sum up, no emoji for that? So unpredictability at a fixed time, we have hockey and baseball. Within season unpredictability, football and basketball. Between season unpredictability, it's got to be hockey. The largest home advantage is in the NBA. So thank you.
So very nice talk. I have a question. At the end, you had the ranking that was this one. That was baseball, hockey, football, and game. Now, if you go back to the slide where you have the calibration curves for the betting market and the traffic light probabilities, the this one, the NHL and MLB have a smaller range, they cover a smaller range, right? NBA goes from 0 to 100, NFL also a little bit, but MLB and NHL have smaller range. Does this impact any way?
Right, so it is true that, I think what we're seeing is that sports like baseball and hockey seem to be more random, right? And so the implied probabilities by the betting markets are not, right, the range is more constrained because there's essentially no game in baseball where somebody's a 90% hitter. Not, and is your question like, how does this relate to this?
Yeah.
Yeah, so that's something that we're thinking about. Do you want to weigh in on that at all? Okay. Yeah, so I think these things are related, you know, to what extent they're related and whether, you know, that's sort of the whole story or just a small piece of the story. That's actually something we're working on for the revision we're trying to submit by everyone. So look for a revision of that paper that answers that question. Yeah.
You hear leagues talking about like the NBA shortening games from 48 minutes to 40 minutes, or the NFL shortening the season.
Right.
Can you predict what that does to the predictability of outcome?
That's a good question. This was another thing that I think one of the reviewers suggested. So, let's just see if we can think through it. So, in a shorter game, it seems like it would only increase the unpredictable, exactly. And so, yeah, I guess, so I think what we can see here is that if you shorten the length of the series in the postseason, right, obviously that's going to increase the variability in those results. And I think what you're asking about is like, well, does that work in games as well?
Yeah,
I assume the answer is yes.
Yeah, I was just wondering if you can quantify that. Like, that might be an important part of making that decision.
Yeah. I don't know how they would do that.
We only have game results.
Right, we don't have game results.
Yeah, like, I don't know.
Yeah.
We need different data sets.
Yeah. That's a good thought though.
Are we going to cut it there?